and in this video again I have taken some more problems of the maxima and minima, just coming into the chapter called the applications of the derivative. So I'll be solving some more questions because that is chapter is called the crux of the differentiation. Now if you see this question I have already copied. Prove that the perimeter of a right angle triangle of a given hypotenuse, means the perimeter of a right angle, you are given a right angle triangle with a given hypotenuse. What do you mean by given hypotenuse? Means the hypotenuse is given, means this length is fixed, and then only you have to draw two sides perpendicular and base. So this hypotenuse h is given, so you can take it as constant, and this is maximum when the perimeter of a right angle triangle of a given hypotenuse is maximum when the triangle is isosceles. So now this is the case that we have x, we can take this as x, axis is y component, it looks like. So I can assume these two sides to be x and y respectively. So the perimeter P will be x plus y plus h, and there is no secret that the y is constant because it is given. So this P is a function of x and y. We need to find another relation so that possibly we can convert y into x. Can you find another relation? The relation exists between this right angle triangle given by the Pythagoras theorem, that is h square is y square plus x square. Therefore y will be under root h square minus x square. So we have our P here is x plus under root h square minus x square plus h. Now without wasting time, let's differentiate this P with respect to x. So dP over dx is 1 plus, what is differentiation of under root? That is 1 over 2 under root x. Differentiation of root x is 1 over 2 root x, and differentiation of root something will be 1 over 2 root something, and that is h square minus x square into differentiation of that something, that is h square, which is a constant, 0 minus 2x plus this h is already a constant, so its differentiation is 0. So now what you are getting? You are getting a relation that is 1 minus 2x upon 2 under root h square minus x square. Now you know that the condition of maxima and minima, that you have to set dP by dx as 0 just to find the value of x. So we can say dP over dx is 0, and that is, now I can cancel this 2 and 2 from here, so that is 1 minus under root h square minus x square, and this is x. So it means 1 equals x upon under root h square minus x square. Now I simply square it from here only to save time. So this is x square and this root is gone. So what you are getting? You are getting x square h square minus x square equal to x square, that is 2x square is h square, therefore x equal to plus minus h over root 2. This is the value of x. You have found that this x should be h over square root of 2. Now we have to find whether at this given function is d square p over dx square 0 or not. So I think I can do it here. So this is my dP by dx. So this 2 and 2 they have already cancelled, so I remove it from here. So d square p over dx square, this is 0. Differentiation of 1 is 0. Now minus, and then we have to find u over v rule, so which says that under root x square minus x square into differentiation of x, that is 1, minus x into differentiation of this whole thing is same like 1 over same like this much. So I can write directly minus 2x upon 2 under root h square minus x square upon square of this thing, that is h square minus x square. So now this minus and this minus make this as positive, and then if I write here, it's okay. So this is, here I can write this minus and this 2 and 2 cancel, this will become plus. So this multiplied with this become h square minus x square, and this is plus x square upon under root, oh, root already is gone, but this one is coming down, so this will become h square minus x square and then under root h square minus x square. These two cancel, so we are getting the whole thing as minus h square over h square minus x square to the power 3 by 2. Now if I put the value of x as positive h by 2, so what do we see the relation here? H square minus x square equals x square. So we have h square minus x square to the power 3 by 2. So if I put the value of x as h square upon 2, so this will become 2h square minus, so I think I need to clear the screen, or I can write here. So I'm getting d square p over dx square as minus h square over, at the place of x I write h by 2. So this becomes h square minus h square by 2 whole to the power 3 by 2. So this is minus h square upon this h square minus, this is 2h square minus h square. So this is h square upon 2 whole to the power 3 by 2. So this h square will become h cube, and this will cancel 2h here, so get 1 upon h, and this 2 root 2, this is 2 to the power 3 by 2, 2 to the power 3 by 2 is 2 to the power half to the power 3, that is 2 root 3. So this 2 root 3 will come here, 2 root 3, sorry, 2 root 2, not 2 root 3. So if this is negative of minus 2 root 3 over h, so if you put the value of h which is already given, now you cannot assume that the hypotenuse is a negative quantity. So you have to assume that this h is always a positive quantity, and in this condition you can see that d square p over dx square is a negative quantity. It means that is maximum, the perimeter is maximum. Now what was the value of x at which this became, this is our, this value, that the x should be equal to h over root 2. So this is x equals h over root 2. Now we have to show that this is an isosceles triangle. It means this y, because this is a right isosceles triangle. In that case, only the perpendicular and the hypotenuse, sorry, the perpendicular and the base can only be equal, because hypotenuse is already a different quantity. So here we have to show that if y is equal to also h square minus x square, and how we do that? We already have this relation h square equal to y square plus x square. So now I use the red ink here. So you see h square equals, what is x square? That is h by 2 square, that is h square by 2, and this is y square. So y square plus, so h square minus h square by 2 is y square, that is, we are getting h square by 2 is y square, therefore y is also h by root 2. So this is h by root 2. So this is an isosceles triangle. So this is called solving the same question using the idea of algebra and the Pythagoras theorem. Now is there any other better way? I find a better way. but let's see whether you also find it the same way. Now I start with the same idea, that this is the hypotenuse and I have H. Now you know the trigonometry was introduced with a very positive notion that can there be a relation between the sides of the triangle and the angle. The answer is yes, because that is the very purpose for which the trigonometry was introduced. Because if you see the ratio between all the t ratios, all this is called trigonometric functions, they are simply the ratio of the sides of the triangles. So here we see that if this angle is theta, so this theta depends on the ratio of this and this, because suppose if this height is increases, like if it increases, then the angle will also increases. If this decreases, then angle also decreases. So if the ratio increases, then the corresponding theta also increases or decreases depending on the direction of the angle. So now here we just simply say that can, if I assume this is as theta, so can I find this side in terms of theta? Answer is yes. So how? So you can say sine theta, I can call this as perpendicular and this is my base. So sine theta is perpendicular upon hypotenuse, that is perpendicular is hypotenuse cos theta. So what is P? H sine theta. If you use cosine rule, you will find B is H cos theta. So the perimeter P equal to H plus H sine theta plus H cos theta. Now this P is simply a function of theta. We can differentiate this directly with respect to theta. We will find d square P over d theta square is, that is constant 0. This is H cos theta minus H sine theta. Now the rule says that first we have to set the dp by d theta as 0. So here you set it as 0. So now you find, since if you take h common, so you find that the cos theta equal to sine theta, or you will find tan theta equals 1. It means the one answer is theta is 45 or pi by 4. There can be infinite solutions for this, but we are taking one general solution which giving us the value of theta is pi by 4. If you take it in the positive sense, otherwise it can be 135, that is also pi by 4. Now we have theta is pi by 4. When theta is pi by 4, then you know already this is 90 degree, and if this is pi by 4, this is also pi by 4 or 45 degree, and when two angles of a triangle are equal, then that kind of triangle is called as isosceles triangle. But you have to show that with the d square P by, sorry, this is not d square, d theta. Now we have to show that the d square P over d theta square is negative. That is important part. So d square P over d theta square. Now differentiation of this is minus h sine theta, and differentiation of this is minus h cos theta. Now you take minus h common. This is sine theta minus cos theta. So in this condition, sorry, plus cos theta. Again I explain from here, this d square P over d theta square is minus h sine theta minus h cos theta, and this is minus h sine theta plus cos theta. If you put the value of theta as pi by 4, so sine theta is 1 over root 2 plus 1 over root 2. These two will be a positive quantity. Therefore d square P by d theta square is minus h, that is negative, for theta equal to pi by 4. Therefore this is maximum, and here the theta is 45 and theta is 45, which means two angles of a triangle are equal. It means their two corresponding sides will also be equal. This is all about this question. So this is how you can introduce the idea of trigonometry also to solve question. Thank you very much. In the next video I'll take one more questions, and then we'll discuss about the idea of the absolute maximum and the absolute minimum in a given domain. Thank you very much. Just subscribe to our channel and stay safe.